Hello, everyone. I've known Sassie Duggleby, CEO of Venus Aerospace, for 3 years. I admire her. I've invested in Venus, and I'm delighted to speak with her at Upfront Summit today.
Yeah.
Sassie, let's get to it. Tell us about Venus.
Yeah, so Venus Aerospace, we are using reusable hypersonic technology that makes platforms that fly further, faster, cleaner, and sooner. And at the core of our technology is a brand new revolutionary rocket engine that enables us to take off from an airport, get out to Mach 4 cruise and fly super efficiently across the globe, and get up to Mach 9 speeds, and we could literally do San Francisco to Tokyo in under 2 hours. And we could do it with 50% of the carbon emissions of a similarly sized plane. So it's totally revolutionary.
You just blew my mind. San Francisco to Tokyo in under 2 hours. I recall you telling me one of your early inspirations was the long time it took for you to fly home from Japan. Can you tell me about that?
Yeah, so in 2018, my husband Andrew and I were deployed to Japan. So we were working at Virgin Orbit, so launching rockets for Richard Branson off wings of airplanes, and got the call because he's in the Navy Reserves. And so living overseas, we had traveled internationally, but we had never actually lived on the other side of the world. And suddenly we realized how big the world is. You know, it's 13 hours to get from Tokyo back to LA. And so literally there was a Sunday afternoon, we were sitting out on our balcony overlooking the Tokyo Bay, and we were talking about how do we get home for my mama's 95th birthday. And we were complaining, it was like, do I take the kids? You're working at the shipyard, jet lag with kids is miserable, if you've ever done that. And he turns to me in that moment and he says, well, you know, there's this new rocket engine and it's coming down the pipeline. It's like, I've been watching it as a professor at Texas A&M and then as head of propulsion R&D at Virgin Orbit. And he said, I think if this engine is ever proven, we could put it on a plane and we could be home in an hour. And I literally laughed at him in that moment. But fast forward, 5 years later, here we are. And we are making this dream a reality.
It's amazing. When you go back to that point in time, what were some of your early challenges in founding Venus?
So really, the key it's the rocket engine, right? And so I'm gonna use this water bottle as an analogy. So rockets, if this is a rocket and I want to fly to space, typically rockets use about 90% propellant. So this entire water bottle is going to be filled with propellant, and you have a tiny little payload on it. So this new engine, which again had been theorized for decades and was finally proven, Andrew said, well, it only needs to be about 67% propellant because it's such an advanced engine. And so what we can then do is say, instead of using this for an orbital rocket and sending more payload to space, what if we turned it this way? And we put wings, and we put landing gear, and we put this engine on it, then we literally could make a rocket plane or a space plane or a high-speed plane actually reality. But the challenge is rockets are hard. So a rocket at its core, one of my favorite analogies is a rocket engine is the equivalent of lighting a fire in a wax fireplace, and you have to keep the wax from melting. And so this new engine, while it had been proven at an academic level, they could only run it for seconds. And so we had to figure out how do we keep this engine from melting such that it can run for 10 minutes, 30 minutes, an hour as we cross the globe. And so that was the heat was the real challenge, and that's what we've been doing the last couple of years is taking this technology and bringing it forward.
Sassie, is this rocket science?
I don't know. You tell me, Phillip.
Well, let's talk about the technology. What about this is a game changer?
So at the core, our engine is called a rotating detonation rocket engine. Our marketing team keeps joking. People hear that, and you probably hear exploding exploder engine, and so we should probably rebrand it. But detonation is actually just the scientific term for supersonic combustion. So go back to Campfire 101. What do you need for a campfire? You need fuel, you need oxygen, and you need a spark. So most rocket engines up until today are just a slow campfire burn in a chamber. And you throttle it, you get your thrust by kind of getting that nozzle like when you put your finger over a water hose. So that's the technology we've been using for 50 years. So the rocket engines that we sent Apollo to the moon with 50 years ago are almost identical to the engines that we send astronauts to the ISS to today. So like the SpaceX engine is about 2% more efficient than the Apollo engine. I mean, and that's 50 years. And so this engine, because we're using detonation, which is, again, just supersonic combustion, it's more efficient, and we get about a 15 to 30% jump in efficiency, which is like total game changer.
So with traditional cryo rocket engines, we've only seen a 2% increase in efficiency over the course of 50 years. It's mind-boggling to me.
Well, and actually, speaking of cryo, so, one of the challenges with rockets tends to be they need cryogenic fuel. So what does that mean? It means really, really cold. So like LOX or liquid oxygen needs to be stored around minus 300 Fahrenheit. And so that's the other massive advancement that we've made at Venus, is we are using room temperature storable propellants. Now that sounds like a mouthful, but what does that mean? I think you were telling me the other day.
Shelf stable.
Yeah, shelf stable. And so we're using in our rocket engine jet fuel. So we literally buy it from the signature FPO right next to us at the Houston Spaceport, and then liquid hydrogen peroxide. So the stuff that's in your bathroom, so hydrogen peroxide is H2O2. The stuff that's in your bathroom is about 3% hydrogen peroxide and then 97% water. The stuff that we would be using is between 72% and 90% hydrogen peroxide, but it's totally storable. You can store it in tanks. There was a mil spec for it, so the military actually used it in torpedoes in the past. And the other great breakthrough we had is typically it's metastable. So when you, not to get too technical, but you have to flow it over a catalyst bed, it splits to oxygen and steam. But because of the temperature that our engine is working at, we can actually just inject it directly. And so we can have it super stabilized peroxide with jet fuel. And it means we can go airport to airport. We don't freeze valves. I think you were telling me about your visit to...
Yes, I was at Starbase in Boca Chica on April 17th to see the Starship launch. And unfortunately, we failed to see it launch due to a cryo issue.
Right. And so
it's very exciting to see that your technology would prevent those things from taking place.
Yeah. So if we were sitting on an airport with a cryogen and a valve froze, so great, you get a 2-hour flight across the globe, but just kidding, we've got to refuel. It's going to take you 12 hours or days. I think it took us 24 hours to cycle a rocket at Virgin orbit because we were using cryogens. So massive, massive breakthrough with the fuels that we're using.
So rotating detonation engines have been published since 1983. They've been in science classrooms, physics classrooms. Why didn't anyone do it until Venus came along?
So really, again, it's been theorized for decades, and it took advancements in 3D additive printing or metal printing. Again, rockets are really hot, and so you have to do all these tricks to keep them cool. And in the past, you have like traditional machining, you haven't been able to make the weird geometries. So additive printing is a massive breakthrough that we were able to take advantage of. And then, the other one is kind of advanced sensors. Like detonation happens at such high speeds. Literally, I think it's 10,000 times per second. If I had a video of our engine, I was pointing up because a lot of times I have one on screen, you would see a detonation wave traveling around and around and around. Well, trying to manage that and keep that detonation wave going was really hard. And so when it was finally proven at an academic level, Andrew, who was a professor at Texas A&M, we intimately knew how far technology, like you could push technology with an academic group. And we said, we've got to go grab this and pull it out and commercialize it. And that's really where, like I always say, God bless the American dream. I mean, it took, venture partners like you guys that could say, yes, this is world-changing technology, and we want to help see this hit the market. And so, exciting times.
Where do you see this technology first being commercialized and stemming from there, where else?
So when we first started Venus, it was all about commercial travel. Like, how does the world change if you can get anywhere in an hour? But I think probably everybody in this room knows that it has geopolitically, the world has changed in the last couple of years. So in 2021, there was this, they literally called it a Sputnik moment when China used some hypersonic systems that we had no idea how far ahead they were as a country. And so I think that was a wake-up moment for the United States and NATO. So really the first place we're focused on is national security. Hypersonics is ranked as one of the top 14 priorities for the Department of Defense. It's also considered one of NATO's emerging disruptive technologies. And so there is a massive interest in hypersonics. To put that in perspective, even this year alone, hypersonic testing for the DoD has an $850 million budget. And so the minute that we have our engine flying on a hypersonic drone, that opens up revenue opportunities that we can, capitalize both to help, kind of protect the Western world, but as it helps us buy down risk such that we can get to this, ultimate dream of a commercial vehicle.
I love dual use. That's what birthed Silicon Valley and some of the greatest airplanes that we've flown commercially. If it weren't for the KC-135, we wouldn't have the 707. If it weren't for the C-5, we wouldn't have had the 747. Venus is the latest example of that. So Sassie, how soon will we see it?
So with the right capital partners, I think we can really, push this technology in the next 5 years. And one of the advances, and I think I called you, was it in October, and told you about this huge engine advance that we had that makes it even that much faster.
I thought we weren't supposed to talk about that.
Well, let's share. I think this is actually the first time we've kind of publicly talked about some of our massive engine advances. If you stop and you watch a rocket launch and you see this giant orange plume, we should all shed a tear because that is heat that we didn't transfer to thrust. And so we've long known that if you could take that rocket and you could mix it with air, it's called air augmented or rocket-based combined cycle, you could get tons of extra thrust and improve your efficiency. But the challenge is it's always been, let's again pretend this was my rocket nozzle. You've got the big giant bell coming off your rocket. The challenge is it's always been about 20 times the diameter of this bell to get that full mixing happening. And so you're not going to add 20 extra times to a rocket when it's already, super flimsy and needs all the payload that it can have. And so they've long thought if you could actually mix that air, we'd get more efficient. And so we ran a test in October because our engine is a entirely different design. We were able to mix and air augment our engine, and it made it so much more efficient that literally we have the engine that can go from takeoff to super efficient Mach 4 cruise and push up to hypersonic speeds if we wanted to. And so to put that in perspective, I think you could do, Houston to London in an hour. We could do, I wrote the numbers down because I don't want to misquote them, and I've already lost my point here.
So October is an eternity ago in aerospace. What should we expect next?
So really, we're in the process of raising capital right now to put our rocket engine on a drone and have it flying, Mach 2, then Mach 4, and continue to push that envelope. And so we should have a Mach 4 plane flying, or Mach 4 drone flying in, the next year.
Anybody interested? What needs to go right outside of Venus's control for this technology in your business to succeed?
Really it comes down to three things. First is government and regulatory. So it right now in the United States is illegal to fly supersonic over land. And so noise or a sonic boom is a massive challenge. So we actually flew a supersonic capable drone last weekend. It was like a huge milestone for Venus. But guess what? We had to throttle it back to below Mach 1 because we didn't have the regulatory clearance to go make that noise. And so there has to be some regulatory hurdles passed. Thankfully, we have been working with the FAA reauthorization this year. And so we actually have a path to push that forward. And I have to give credit to some of our congressional partners, both on the House and the Senate side, in helping us get this language such that we can make this actually happen. Second, we need strategic partnerships. Some people always talk about full vertical integration. But we're looking for the best partners to join us on this journey such that we can push this technology out as fast as possible. And then third, it comes down to capital partners. I truly believe we have the world's best investors on this journey with us. So we have, folks like you. We've got Prime Movers Lab. We've got Airbus Ventures. We have folks that truly understand how to take deep tech plays and actually make them a reality. But we want more of the world's best to join us on this journey as we absolutely make this a reality.
Sassie, you brought up the point of sonic boom. At what altitude do you no longer hear the sonic boom?
So that's a great question. So we actually know from the space shuttle. So when the space shuttle is in orbit, it's flying, and it slows down. And it would cruise, from Japan to Florida in about an hour. And so we're really just repeating kind of what the space shuttle did. But we happen to know that nobody in Kansas, when the space shuttle flew overhead, nobody looked up and said, what was that? It actually wasn't until we got down near Florida that the shuttle, suddenly heard the kind of classic boom where it was like a double boom. And so that altitude is around 110,000 feet. Well, Venus, because we're a rocket, we actually can fly higher than that. And so, here's a question for you, Phillip. What's the difference in a rocket and a jet?
Well, a jet needs oxygen, relating back to your campfire analogy.
Yeah. So our entire premise at Venus is instead of being a fast-flying jet, let's be a slow-flying rocket. And so the difference, rocket and a jet brings its oxygen from the atmosphere. As a rocket, we carry our own oxygen with us, which means we can go way higher in the atmosphere and fly way cooler. Did you see Top Gun Maverick?
Of course.
How many of you guys in the audience saw Top Gun Maverick? Woohoo! All right, pretty good answer. I see some people without their hands raised. But Top Gun Maverick was the perfect story for Venus. Because what happens in the very opening scenes?
Well, he tries to achieve Mach 10 and it doesn't work.
Yeah, why doesn't it work? He melts his vehicle. So if you're trying to push your jet engine or your jet-powered plane up to hypersonic speeds, it's literally like flying through soup. You have to fly low enough in the atmosphere to feed your jet engines with the oxygen, and flying that low, it's soup. And so you have massive heat challenges. And so literally the entire premise of Venus is don't be a fast-flying jet, just be a slow-flying rocket.
I love that. That's a great slogan. Sassie, I remember flying the Concorde. Why isn't it flying today?
Yeah, I wish I flew the Concorde, but we're building something better. So really the Concorde failed for a couple reasons. One was noise. So both their engine was really loud at takeoff, all the neighbors complained, and then they had the sonic boom issue. So I think originally they were actually flying over land, and a bunch of countries got angry because they kept making a bunch of noise, and so they were restricted to transoceanic routes, and so it just limited the amount, kind of the economics they could have. And then the other challenge again is if you want to be that fast-flying vehicle, well, really you're going to have those heating problems. And so anybody that's tried to push a little higher, I think earlier we were talking about the SR-71. That's one of my favorite stories. So the SR-71, literally when it sat on the ground, it leaked fuel like crazy because when it was flying, it was going so hot that all the metals expanded, and so it had to be able to have thermal expansion. And so again, it's really hard to be a fast jet. You want to be a slow rocket.
So as we're talking about this, I'm wondering about affordability. Will everybody in the room be able to afford this on a United ticket?
Well, here's my question, Phillip. What's your time worth? Right? So, our ultimate goal is to keep the, prices down to kind of first-class ticket prices. But at the end of the day, Venus is more of an airline supplier. We don't intend to be an operator. And so that's for the market to decide. There's actually a ton of research studies out there that show, it could be 5x times first-class ticket prices. But our ultimate dream is to keep that price low to create a more connected world.
I agree with that completely. Anytime you're able to move people and goods across the world faster and greener and at a lower cost, you're going to see economic advancement.
Yeah.
What is it that keeps you up at night?
We have the engine. Like we have it. We have the engine that is the total game changer. And really the question is, how do we get this engine to market fast enough to make a difference both on a national security level, but then ultimately on a commercial level?
And what's your ultimate vision? What is your North Star?
You know, the real question I ask is, if you look back at the history of transportation, so as we went from, horses to trains to automobiles to propeller airplanes to jet airplanes, every single time we have had an increase in transportation speed, we've actually had an increase in peace and prosperity. So if you think about it, we're not at war with Mexico. We're not at war with Canada. They're our neighbors. We're super connected. And so the question that we really ask ourselves and our ultimate vision is, how does the world change if we are all completely connected? We would be able to have you're a businesswoman and you have a meeting in Tokyo. You could literally leave San Francisco in the morning, fly over to Tokyo, have your meeting, and you could actually get back home for dinner. And as a mom who has two daughters that are, pretty quickly going to leave the house, which makes me really sad, like that impact is super empowering. So
I've been curious about the name Venus Aerospace. Why did you name the company Venus?
Yeah, that's a great question. So it was really two reasons. So when I was working at Virgin Orbit, I was the oldest female engineer. Like I was 38. I don't think that's old. Maybe you do, but and so it made me look around the room. There were tons of 25-year-old female engineers, a few 30s. By the time you got to almost 40, like none. And so it made Andrew and I question, what's wrong with the industry? And so some of it, Venus is the only female planet. If you think of all the names, Mars, Jupiter, Saturn, they're all named after Roman gods. Venus is a Roman goddess. And she also happens to be the goddess of love. And so we have a premise of what would it look like if we actually loved our employees well? And that might sound cheesy, but we want you to be home for dinner. I've got to be home with my kids. And so we truly believe that we can do something different. And not only are we going to kind of change the world with the technology we're doing it, we're also trying to build a culture and how we operate that's very different than what the rest of the world says is normal.
What are some of your biggest wishes in terms of partnership? You mentioned partnership, and you and I talk about building the village, being vertically minded as opposed to vertically integrated. Do you have any dream partners or anything on your wish list?
So I don't want to name names, but there's some of the world's best companies out there that we've been chatting with, both from a defense application and from a commercialization application. And so, we want to work with the world's best. And really, some of like Lockheed Martin Skunk Works, they were able to take something from nothing so fast. And so how do we find those partners that can help us really, really push this forward? Because the world absolutely needs what we're building. And the other thing I'll say is, one of the reasons I ended up connected with Phillip is because I was actually looking for more women on my cap table, and I got Phillip, but not going to complain.
Sorry about that.
I know. But a lot of times women are afraid of aerospace. They're afraid of STEM. They're afraid of engineering. And even from an investor standpoint, I saw that. So I would love to have some of the world's most incredible women to join me on this journey.
The time has flown by at the speed of Venus. I know the audience joins me in thanking you for being here today.
Yeah. Well, thanks. So appreciate it.
Sassie.